Assalamu alaikum and welcome to Cambridge Chemistry with Sarwat Ahmed. In this video I will explain group 2 similarities and trends in the properties of the group 2 metals magnesium to barium and their compounds. Candidates should be able to describe and write equations for the reaction of the elements with oxygen, water and dilute hydrochloric acid. So we know that the magnesium in group 2, beryllium, magnesium, calcium, strontium, barium and radium. This is radioactive. Radium is radioactive elements. So the electronic configuration of the 1s2 2s2 1s2 2s2 2p6 3s2 1s2 2s2 2p6 3s2 3p6 4s2. They all are very reactive metals, second to group 1. All alkaline earth metals react with water or steam except beryllium. All the metals burn in oxygen to form normal oxides. All these metals are strong reducing agent because they have low ionization energies and readily donate electrons. For example, reaction of element with oxygen, magnesium plus O2 to form MgO with dazzling flame, white dazzling flame. Calcium react with oxygen to form calcium oxide with brick red flame, and strontium react with oxygen to form strontium oxide. This is bright red, this is brick red flame, and this will burn with bright red crimson flame, and barium plus oxygen to form barium oxide with apple green flame. So these are the reaction with the oxygen. Describe the right equation for the reaction of oxides, hydroxides with water and dilute hydrochloric acid. Magnesium oxide with water, magnesium hydroxide, calcium oxide plus water, calcium hydroxide, and strontium plus water, strontium hydroxide, and solubility of hydroxide increases down the group, and barium oxide react with water to form barium hydroxide. Solubility increases down the group. Magnesium react with water to form gaseous state. In steam, reaction is very vigorous. Solid plus hydrogen gas is formed. Calcium sinks in water and reacts in cold water evolving hydrogen gas. Cold water CaOH twice plus hydrogen gas. Similarly, strontium reacts vigorously with water to form strontium hydroxide, strong alkaline solution like group 1 hydrogen gas. And similarly, barium also reaction is very vigorous, liquid solid to form barium hydroxide plus hydrogen gas. So these are the reactions with water, oxide with water. Next is the decomposition, thermal decomposition of metal carbonates to form calcium oxide, respective metal oxide and carbon dioxide. Magnesium carbonate to form MgO plus CO2. Similarly, calcium carbonate, calcium oxide plus CO2, and barium carbonate to form barium oxide and carbon dioxide. Thermal stability is increased down the group, or it becomes more difficult to decompose a carbonate with increasing polarizing power. Reason is not required, just trend is required in AS, that thermal stability of the carbonates are more stable. Any metal compounds of group 2 are more stable down the group. More heat is required. For example, if let's suppose if 100 degree centigrade, over here 200 degree centigrade, 400 degree centigrade temperature is required. So it means thermal stability increases down the group. Thermal decomposition of the nitrates are, all nitrates gives metal oxide, nitrogen dioxide, brown colored gas nitrogen dioxide, and colorless gas oxygen. For example, beryllium nitrate NO3 twice to form BeO plus nitrogen dioxide plus oxygen gas 4 2 and 2. Similarly, magnesium nitrate also decompose like this. All metal nitrates decompose like this: magnesium oxide plus nitrogen brown colored gas nitrogen dioxide and oxygen gas. So these are the reactions of nitrates. Describe and write equations for the oxides, hydroxides and carbonates with dilute hydrochloric acid and sulfuric acid. You know that magnesium oxide react with sulfuric acid to form MgSO4 salt plus water, and similarly with hydrochloric acid MgO plus HCl to form magnesium chloride and water. Similarly, hydroxides, magnesium, let's say magnesium hydroxide, react with HCl to form magnesium chloride plus water. So this is the equation of oxides. And carbonates also react with acids, just like magnesium carbonate react with all metal carbonates of group 2 react with acids to form salt, water and carbon dioxide. MgCl2 plus water plus CO2. Describe and write equation for thermal decomposition of nitrates, carbonates to include trends in thermal stability. Describe and make prediction from the trend and physical and chemical properties of the element involved in the reactions in 10.1.1, and the compounds involved in 10.1.2, 10.1.3 and 10.1. State the variations in the solubilities of the hydroxides, and hydroxide solubility of hydroxides increases. This is increases down the group, and sulfate decreases down the group. Solubility of sulfate decreases down the group. And this is the physical properties. Melting point, boiling point decreases down the group. Atoms, ions get larger. The distance between nuclei increases, nuclei and electrons increases. Bonds become weaker. Similarly, melting point, boiling point higher in group 2 than group 1. 2 electrons per atom donated into delocalized system. Metallic bonding stronger in the group 2. Density increases down the group. Mass of atomic atoms increases faster than their size as atomic number increases. So this is these are the physical and chemical properties of group 2 elements. So next, group 17. Group 17, trends in color and volatility. Fluorine is yellow in color, chlorine is yellow green, bromine is orange brown, and iodine gray solid. This is the states. Fluorine and chlorine exist in gaseous state, bromine liquid state, and iodine exist in solid state. Melting boiling point increases down the group. Volatility also decreases down the group. The color gets darker down the group. So astatine is black in color. Oxidizing ability. Halogens have high electron affinity. They gain electrons, hence they are good oxidizing agent. This is very important to learn, that they are good oxidizing agent after gaining of electron. Oxidizing ability decreases down the group because electron affinity decreases as atomic size increases. Reaction of halide ions. HF reacts explosively in all conditions. HCl reacts explosively in sunlight, while HBr reacts slowly on heating. HI forms an equilibrium mixture on heating. Thermal stability of halogen hydrides decreases down the group. Due to the size of halogen atom increases, nuclear attraction to the outermost electron is also decreases. The HX bond becomes longer and weaker, thus less energy is needed to break the bond down the group. Bond energy decreases down the group, but bond length increases down the group. Halide ions with aqueous halide ions. Ag, you know that silver ion plus halide ions to form silver halide compound in solid state. Halide ions chloride ion form white precipitate with silver nitrate. Bromide ions form creamy precipitate with silver with the bromide. For example, this is the Ag plus Cl to form AgCl. This is ionic equation. Silver nitrate and sodium chloride, aqueous. Ag silver nitrate plus bromide ion to form AgBr, solid. This is creamy white precipitate form silver bromide form creamy precipitate, and silver iodide form yellow precipitate, silver iodide. So with dilute aqueous ammonia, precipitate dissolves. Silver chloride precipitate dissolves in dilute ammonia as well as with concentrated ammonia. And similarly, bromide precipitates dissolve insoluble in with dilute ammonia but soluble in concentrated ammonia. and iodides form yellow precipitate which are insoluble in both dilute ammonia as well as in concentrated ammonia. Silver chloride dissolves to form a complex sign like silver solid when react with ammonia to form this complex sign plus X2. This is the structure of the complex sign. The complex sign formed is called diamine silver 1 ion. Subhalide ions are aqueous sulfuric acid. Metal halides plus concentrated, this is also very important reaction of halogens. Metal halide plus concentrated sulfuric acid, hydrogen halides are formed. Concentrated sulfuric acid is an oxidizing agent except for chloride and fluoride as it is not strong enough. So, concentrated sulfuric acid cannot oxidize HCl and HF, cannot oxidize HCl and HF because HCl and HF is more stronger oxidizing agent than sulfuric acid. This reaction is used for the preparation of hydrogen halides. For example, with chlorine, when sodium chloride reacts with sulfuric acid, HCl plus sodium hydrogen sulfate is formed. This is not further oxidized with sulfuric acid because HCl is a strong oxidizing agent than sulfuric acid. But in case of bromide, NaBr react with H2SO4 to form HBr plus sodium hydrogen sulfate, or hydrogen bromide is further oxidized by sulfuric acid because HBr is weaker oxidizing agent than the sulfuric acid to form bromine gas plus sulfur dioxide plus water. Similarly, iodine form a variety of chemical equations. So, iodine sodium iodide when react with sulfuric acid to form hydrogen iodide and sodium hydrogen sulfate, and hydrogen iodide further oxidized by sulfuric acid to form iodine plus sulfur dioxide and water. If it is also into another products are also formed, iodine plus hydrogen sulfide plus water. Similarly, hydrogen iodide react with more hydrogen iodide react with sulfuric acid to form iodine, sulfur and water. So, these are the reactions of chloride, chlorine, bromine and iodine with strong sulfuric acid. So, please keep it in mind that sulfuric acid is not further oxidized HCl and HF, but bromine HBr, HI can be further oxidized with by using sulfuric acid. So, this is the preparation method of making HCl, HBr and HI. The reaction of chlorine with aqueous sodium chloride, this is also very important reaction. This proportionation reaction, the reaction in which the same substance is oxidized and reduced simultaneously, producing two different products. When chlorine reacts with a solution of cold aqueous sodium hydroxide, the disproportionation goes to lower oxidation state. Chlorine plus sodium, this is with cold. Chlorine plus sodium hydroxide to form NaCl minus and over here plus 1. So, chlorine is both oxidized and reduced in the reaction. So, that is why this reaction is known as disproportionation reaction. So, when hot solution of sodium hydroxide is used, chlorine is oxidized to form NaClO3 plus sodium chloride plus water. In this case, the oxidation state is 5 and over here minus 1. So, the ionic equation for this reaction is Cl2 plus 2 OH negative to form Cl negative plus ClO negative plus water. Similarly, for in this case 3 Cl2 plus 6 OH negative to form ClO3 negative plus 5 Cl negative plus 3 H2O. So, these are the ionic equation for this reaction. This happens as the chlorate is formed. So, disproportionation of hydrogen hypochlorite and hypochlorous acid. So, ClO negative plus HClO negative to form ClO3. This is also very important reaction. Higher temperature promotes the formation of hypochlorous acid through the hydrolysis of hydrochloride, hypochlorite, and therefore speed up the rate of reaction. Important uses of halogens and halogen compounds to make chlorofluorocarbon as fluoride in toothpaste, to make polytetrafluoroethene PTFE non-sticking coating in pots and pans. Bromine and iodine manufacture of photographic films of chlorine in bleaches to make PVC and chlorofluorocarbons as solvent. Use of chlorine water in purification. The oxidizing power of chlorine is used in the treatment of water to kill bacteria. This is also very important reaction from examination point of view. Chlorine plus water to form HCl plus HClO, and this HClO kills the germs in water. This disproportionation reaction produces reactive oxygen atom which kill bacteria. This atom kills bacteria. This is very reactive and it kills bacteria. Next topic is nitrogen and sulfur, lack of reactivity of nitrogen. Nitrogen molecule has 3 strong covalent bonds. The bond is very strong, activation energy is very high, requires high energy to separate the 2 nitrogen atoms of molecule. This is the molecule. It reacts only under extreme temperature or pressure in the presence of catalase to form ammonia. Lone pair of electrons of nitrogen atom forms a coordinate bond with hydrogen ion, formation NH3 plus H positive to form NH4 positive. Shape is tetrahedral, bond angle is 109.5, bond length is equal length, that is ammonium 109.5 degree. Displacement of ammonia from its salt. Any ammonium salts when react with the base to form ammonia gas, for example NH4Cl plus calcium hydroxide or any other base to warm the solution, ammonia NH3 plus calcium chloride, and ammonia gas is evolved. Uses of ammonia and its compounds: used in production of nitric acid, used in production of inorganic fertilizers, used in production of nylon, used in the production of explosives. Oxide of nitrogen, nitrogen plus oxygen to form nitrogen monoxide, and nitrogen plus half oxygen to form nitrogen dioxide. So in this way oxides of nitrogen are formed. Naturally, during lightning, activation energy provided for nitrogen to react, man-made in car engines, high temperature and pressure. Catalytic converter: exhaust gases pass through catalytic converter containing a catalyst, platinum, palladium, helping to reduce oxides to nitrogen. This is the catalytic role in oxidation of sulfur dioxide. Nitrogen monoxide with oxygen to form nitrogen dioxide. Nitrogen dioxide react with sulfur dioxide to form sulfur trioxide and nitrogen monoxide. Nitrogen monoxide is regenerated in this reaction, so nitrogen monoxide used as a catalyst. So sulfur trioxide in this reaction which is produced react with water, rainwater to form acid rain. So these are the reaction to produce acid rain. So two compounds, this is also very important reaction. So nitrogen dioxide react with water to form 2 types of acids are formed, nitric acid and hydrogen nitrite. And this is the reaction 4NO2. This is another, you can write down this like this. Damages, acid rain damages trees, plants, kills fish and other river life, buildings, statues and metal structures. Combustion pollutants: nitrogen monoxide formed by the reaction of nitrogen and oxygen in the engines forms acid rain and respiratory problem. Photochemical smog is also formed. Atmospheric oxides of nitrogen monoxide, nitrogen dioxide can react with unburnt hydrocarbons to form peroxyacetyl nitrate, which is known as PAN. which is component of photochemical smog. So the main oxide of nitrogen form acid rain, respiratory problems, and for photochemical smog. Unburnt hydrocarbons to form peroxyacetyl nitrate, PAN, which is a component of photochemical smog. Carbon monoxide source, incomplete combustion of hydrocarbon fuel, toxic effect on hemoglobin. Food preservatives. Sulfur dioxide is used by itself or as a sulfide to preserve food. Sulfur dioxide plus water to form sulfurous acid. Sulfur dioxide and sulfides inhibit growth of bacteria, yeast, etc., and are reducing agents, so reduce rate of oxidation of food. Used to prevent spoilage of dried fruit, dehydrated vegetables, and fruit juices. So I have discussed all these properties, just like relative reactivity of elements as oxidizing agent, describe the reaction of elements with hydrogen, and explain the relative reactivity in these reactions. Describe the relative thermal stability of hydrogen halides and explain these in terms of bond strength. Longer the bond strength, weaker the bond. If bond length is increases, bond become weaker, and less bond energy is required to break the bond down the group. Some halide reactions of halide ions also discussed. Describe the relative reactivity of halide ions as a reducing agent. Down the group, relative reactivity of reducing agent is increased. Describe and explain the reaction of halide ions with aqueous silver ions by aqueous ammonia, that the formation of formula of the AgN. This is also this because it is written in the syllabus. So this reaction is also I have discussed earlier. Concentrated sulfuric acid to include balanced chemical equation with dilutes and with cold dilutes sulfuric acid, and as well as with hot concentrated sulfuric acid, and this reaction is disproportionation react. This is the sulfuric acid act as an oxidizing agent and which react with the salt of halide ions. This is that is disproportionation reaction is with sodium hydroxide. Describe and interpret in terms of changes in oxidation number the reaction of chlorine with cold and with hot aqueous sodium hydroxide, and recognize these as disproportionation reaction because chlorine is oxidized and reduced at the same time in the same reaction. With cold, NaCl plus NaClO plus water is formed. I have earlier discussed these reactions. Explain, including by using FN equation, the use of chlorine in water purification to include the production of the active species HOCl and ClO negative, which kills bacteria. So water when water react with chlorine to form HClO and HCl, and HClO is further decomposed to form HCl and nascent atomic oxygen, which is very reactive and kill the bacteria. Nitrogen and sulfur, I have also explained the nitrogen and sulfur earlier. Lack of reactivity of nitrogen due to presence of triple bond, and bond is very stronger, so high activation energy, lack of polarity, non-polar, so that's why high energy is required to break the nitrogen molecule. The basicity of ammonia using the Bronsted-Lowry theory, for example NH3 plus water. So the Lowry-Bronsted theory, ammonia is a base, water is a acid. So this is conjugate acid plus OH ion, conjugate base. This is conjugate acid, so this is also very important. This is acid because this is base, proton acceptor is a base and proton donor is an acid. So water is proton donor, ammonia is a proton acceptor, ammonium ion is conjugate acid, and hydroxide ion is conjugate base. The structure of ammonium ion is tetrahedral to form by an acid base reaction. The displacement of ammonia from ammonium source by acid base reaction, for example ammonium salt react with sodium hydroxide or any base to form NaCl plus ammonia. This is also neutralization reaction plus water. State and explain the natural and man-made occurrence of oxide nitrogen and their catalytic removal from the exhaust gases of internal combustion engine by using catalytic converter. Understand that atmospheric oxides of nitrogen monoxide and nitrogen dioxide can react with unburnt hydrocarbons to form peroxyacetyl nitrate PAN, which is component of photochemical smoke. Describe the role of nitrogen monoxide, nitrogen dioxide in the formation of acid rain, both directly and in their catalytic role in the oxidation of atmospheric sulfur dioxide. I have discussed all these points earlier. So this is all about the inorganic chemistry, their important reactions, their important characteristic features. Hopefully you understood, and if you understood, please like the video and subscribe the channel.